Montaigne. This gentleman here on my right is Frédéric Boutoul, specialist in medieval history, full professor at University of Bordeaux Montaigne, the Vice President of Research, to say a few words for the institution for this international congress. Frédéric?
Thanks for me. Well, I said, on behalf of Hélène Velasco-Gracier, President of our university, I'm very pleased to welcome all the Congress, participants of the 14th Congress of the European Meeting of Ancient Ceramics here in Bordeaux, 2 years after the last workshop organized in Athens. Bordeaux is considered by the Lonely Planet, as you know, in the 10 most attractive destinations in the world, and according to the Los Angeles Times, the first French town for its touristic attractivity. So you'll see that Bordeaux is a very nice place to study, to work, or to teach. Bordeaux Montaigne is the smallest university of the two universities located in Bordeaux. It's a 16,000 students university, mostly dedicated to humanities, languages. 23 languages are taught in our university. Archaeology, philosophy, arts, history, geography, communication. The other one, with which we are strongly connected, is the University of Bordeaux, mostly dedicated to science and technology. The Research Institute of Archaeomaterials, IRAMAT, is a joint laboratory of CNRS, French National Center for Scientific Research, and the Bordeaux Montaigne University. It's the IRAMAT organized, as you know, this workshop. IRAMAT is one of the best research team of our university. It's a major contributor to the excellent results of archaeology in Bordeaux. As you certainly know, Bordeaux is first one for, according to the QS World Ranking by subject in archaeology, and is alongside with two other research teams, Ozonius and PASEA, with which IRAMAT is associated in the Bordeaux Archaeological Science Cluster of Excellence, the LABEX-LASCARB. The Research Institute of Archaeomaterials is a very attractive team for researchers positioned as junior chair, successful in many applications, and call for projects are those launched by the region, New Aquitaine, the National Research Agency, Agence Nationale de la Recherche, or by European Research Council. I'd like to thank all the colleagues for the organization of this Congress. First of all, Rémi Chapouli, IRAMAT Director, Nicolas Frerbeau, Nadia Guérin, Nadia Quentin, Ayed Ben Amara, Sophie Philippot, and all the members of the Planning Committee for this remarkable scientific and international program. And I'd like to thank also all the New Aquitaine region, the Bordeaux Excellence Initiative, and all the partners involved in this Congress. The Bordeaux Montaigne's support for this Congress is due not only to the quality of the past Congress. Bordeaux has a past tradition in ceramics, developed during the 19th century in a huge factory directed by Johnson and Villard, producing famous earthworks which reflected tastes and influences of that time from England, from China, from Japan. Among these numerous activities, the Research Institute of Archaeomaterials will soon begin a research program on this flagship of the past industrial landscape of Bordeaux, with fundings from the region New Aquitaine. These are some reasons why Bordeaux Montaigne couldn't fail to support this Congress and its organization. I wish you an excellent work and a nice day in Bordeaux.
Okay, I'll keep the microphone for 1 or 2 minutes more before introducing the official introductory conference that's going to be given by our colleague Agnès Smith. Because myself, I'd like to say, as I said, welcome again in the metropolis of Bordeaux that we like and which has become more and more famous due to some probably very good reasons. Frédéric has just said a few words on that. And very soon, due also to this European meeting on ancient ceramics, with no doubts. Actually, and to tell you the truth, when we submitted our proposal in the Athens meeting 2 years ago for the organizing of the EMAC 2017, we did not know what was going to happen. I received an email yesterday from Vangelio, the director of the Fitch Lab in the British School in Athens, and who was member of the organizing team with Vasilis and many others. And the email was said, I remember it was quite stressful, but very rewarding and enjoyable experience. I hope it's the same for you and your team. Yes, Vangelio, it is stressful, and we do hope it's going to be enjoyable. We will see on Saturday how we feel. And to start with, I want to thank all the people from my lab who did a tremendous work during the preparation step. Frédéric has mentioned Nicolas Frerbeau, who is postdoc fellowship in Paris at the moment, and who could take some time off to be with us during these days. Nadia Quentin, engineer at the CNRS, specialist in petrology, ceramics. Ayed Ben Amara, assistant professor, specialist in ancient ceramics too. Sophie Philippot Le Camus, in charge of the administration and finances in our lab, the key person. Pierre Machu and Brice Lebrun, both finishing their PhDs in our lab. And all the members of the so-called IRAMAT CRP2A laboratory who contributed to this adventure. Also to be quoted is Lionel Cazot from our University Bordeaux Montaigne, who released the abstract book. I guess everybody's got the little bag. You all know what that is and how important it is. It must be somewhere. And the people at the communication office and the cluster of excellence who gave help and financial support, as did the Fédération of Archaeological Sciences of Bordeaux, FSAB. Financial supports were also obtained from our university, from the CNRS, from the Région now called Nouvelle-Aquitaine since last year. And the sponsors are to be quoted, Prezi, Microvision, Hierarch, Synergy, and Zeiss. Thanks to them. Now, what about science? Scientific committee did a wonderful job, thanks to them. They helped to accept, sometimes refuse, the 200 abstracts that we received. 57 as oral communication were then accepted and 117 as posters. The topics are well exposed in the little book, as I said, as well as the members of the scientific committee who accepted to chair the sessions. Klaus Bente will open the first one after the introductory conference, then other colleagues will follow. As I asked to the chairman and women, so I asked them to try to skip to the timetables and to be as perfect as possible in managing the talks. But we prepared a thing like saying, you know, there's 5 minutes left, there's 3 minutes left, there's 1 minute left, and this is sorry, time out. In 2 versions, so Klaus, you'll know. You start with it. 15 minutes are given to the speaker and 5 minutes for discussion. Obviously, the coffee breaks will allow to carry on with when you feel like it. That brings me, to the surroundings and the social events. Lunches, they're all to be taken in the room next door called Salle Badiane. For those of you who have tried the coffee already, you already know what that is. So coffee breaks, lunches over there, okay? Wednesday night, I think that's today, isn't it? Tonight is the cocktail with something we thought might be enjoyable. Wine session with a professional who will inform you about the wines that you will taste. Then the evening is free. During the cocktail, I will suggest those of you who are already thinking about a future, that is EMAC 2019, if I'm right, to get in touch with me maybe so I can inform everybody then. If many candidates, then we will proceed to a vote as democratic as it was carried out in Athens. And this should be done during the lunch on Thursday. Thursday night, there will be the moment for the conference party, gala dinner. Those of you who registered will be informed. The meeting point is 9 p.m. at Café Maritime. Tramway, that's the best way to move into Bordeaux City. Tramway is line B, but we will give details. It brings me to a very important point, and as I said, the transportation. Please use the tramway, so easy and efficient. Line B to come to this place, Forum stop, and back to downtown city. On Friday, we would like to get a picture, a photography of to those of you who will still be there, hoping everybody will stay. This should be at the end of the session, at noon and a half, something, in front of this building. So be there, ties are allowed. But the way this building, by the way, this building used to be an ancient church of the 12th century, I guess, something like that. Frederick will confirm, he's a specialist in medieval history. Okay, and Saturday, because Friday night is the official ending of the Congress, Saturday is the outdoor excursion at Arcachon, which is about an hour ago from Bordeaux Center. Information then will be given later on the Friday, probably, on Friday. Starting moment has been decided to be the 8:30 from here, I guess. And also important point is to be informed probably tomorrow, the publication of the proceedings. We're already thinking of this because this is a very important point. All scientists know that. We would suggest to take advantage of this review that is called Archaeoscience, who is run by one of our colleagues from the EMAC laboratory settled in Rennes University. But he'll be there tomorrow, probably giving PowerPoint to send details. And about this, rapidly, about the calendar, by the 1st of February, we would ask for the full text version to be submitted. That's a possibility, 1st of February. Then the review could be released by the end of the year 2018. That is what I heard. And so now, we will listen and talk science, and I'm very glad to invite Agnès Smith, my colleague from the University of Limoges. And very quickly, a few words. Agnès graduated in a school of chemistry in Paris some time ago. Then she also specialized in metallurgy in the University of Pierre et Marie Curie in Paris 6. And she went also to Orléans with a doctorate in material sciences, then a postdoc in Canada at Queen's University in Ontario, and back to France. Then she successively got a lecture position and professor at the universities, specializing in industrial ceramics. And she's been director of studies. Now she's in charge of research activities in the field of hydraulic binders in the lab called Study Group of Heterogeneous Materials. Agnès is a member of the board of directors of the Ceramics Competitiveness Cluster, the European Ceramics Cluster. And we're quite happy to have her with us today in this Congress, because it happens that we are now partners in a future program that will start very soon under the direction of my colleague Ayed Benamara, with the financial help of the Région Nouvelle-Aquitaine, a project called Johnston Vieillard, manufactured Bordeaux in the 19th century, historical and technical approaches and European influence. So, where we will have to cooperate by studying ancient ceramics with some of the methods available at Limoges. So now, Agnès, this is your turn with your conference entitled Current Trends in Ceramics. Thank you.
So, good morning, ladies and gentlemen. And first of all, I would like to thank very much the organizer to talk to you about the current trends in ceramics. Just to say to you where I am working, so our research laboratory called Ceramic Processes and Surface Treatment is located in Limoges, in France. And the research is on the understanding and the mastery of the ceramic processes and surface treatments in order to manufacture ceramic pieces with specific properties. So we're about 200 people, including roughly 100 PhD and postdoctoral researchers. Concerning the activities on construction material, it's part of what we call Carnot Institute, called Materials and Equipment for Sustainable Construction. So the idea of the Carnot, which is a French network equivalent to the Fraunhofer in Germany, is to bring public research and industry together in order to respond to the corporate need for innovation and to dynamize their activities and support their competitiveness. So before showing you some example of ceramics, I have a little movie I would like to show you, which was made by our master students and some of our young colleagues, showing some everyday application of ceramics. So where is the film? Here we go. So, as you can see, this was a little movie showing, some application of ceramics. Okay. So, in fact, we have, at the present time, there are many ceramic processes to manufacture the ceramics, like extrusion to make hollow pieces, tape casting to make supple ceramics, 3D printing, pressing, physical vapor deposition, and so on. And you've seen through this little movie that many sectors are concerned by ceramics. So health with prosthesis and bioceramics, communication, electronic devices, you've seen the computer, nonlinear optics, glass fiber to transmit what you use for transmission of waves, transport, aircraft, car, satellites, tableware, porcelain. Of course, Limoges is known for its porcelain. Energy sector, like solar panel, nuclear fuels, refractories, building, cement, concrete, glass, plaster, tiles and brick, and environment. So today I will focus my talk about the environment, and I will talk about I will give three examples. The first one is on the recycling and valorization. The second one is how to develop ceramics to have better comfort in houses. And the third example would be on the use of eco-friendly additive in one of the ceramic process I've shown, which is tape casting. So let's start with the first example, which is the recycling and valorization of damp sediment in the cement industry. So here is an electric and hydroelectric reservoir. So because usually it's close to a mountain, there is sediment deposition due to watershed erosion. There is solid transfer by the watercourse, and the biggest particle, that is to say sand and gravel, deposit at the entrance of the reservoir. And the finest particles stay in suspension, and eventually they accumulate at the bottom of the reservoir, which gives, for instance, this huge muddy accumulation shown here on this photograph in a reservoir in the French Alps. These accumulations have several impacts. First of all, it reduces the reservoir capacities. Second consequence is the environmental consequence, because it modifies the watercourse morphology and has impact on the aquatic life. And also it impacts the recreational activities. So therefore, there is a need to have an adequate and sustainable management of these sediments. First thing which is done by EDF, which is the French operator for electricity, is to remove these sediments and store them on land. But because the regulation will evolve very shortly, the landfill option is not the long-term solution, so we have to find beneficial reuse of these sediments, but obviously this needs some work. So in the laboratory, we've looked at several routes to valorize these sediments, to manufacture ceramic products, to use them as cement, to manufacture cement, concrete, layer in road construction, or agronomic uses. So today I will talk only about the uses to make cement, because it can absorb the highest volume of these sediments, with two possibilities. The first one is to use these sediments, as an alternative raw material for clinker manufacture. The other possibility is to use these sediments as pozzolanic addition to Portland clinker. So this work is a project which we've done with EDF and Technical Lab and the Association of the Cement Industry. Just a quick background as how do we manufacture a clinker. So it's a mixture of limestone, which is a source of calcium oxide, which is noted C in the cementitious industry, plus clay, which is a supply of silica, alumina, iron oxide, notation S, A, and F. After crushing these raw materials and homogenization, there is a sintering stage at a high temperature, 1450, and we obtain four mineral phases, which are calcium silicate, alite here, C3S, belite, calcium aluminate, and calcium aluminoferrites. These are air quenched, and then after the clinker is crushed, we obtain the cement, which is mixed with different additives to have the proper setting characteristics. So the idea is, would it be possible to replace part of the clay or the limestone by these sediments? Because, as you can imagine, these sediments are rich in all these oxides which we find in the clinker. So in France, Bordeaux is here, Limoges is somewhere here. There are various dams which are widespread all over the French territory. So because of this distribution, there are various geological and pedological contexts, and also there are variations in sediment characteristics from one dam to the other. So what we have decided to do is to select 7 dams on the basis that they were close to a cement plant, and that because of this proximity, they could be of potential interest for a valorization in the cement plant. Here is an example of 3 sediments, C1, R1, S1. So our reference mix, so you have 76% of limestone, 23% of clay, and the idea is to substitute part of the clay, or completely the clay, plus part of the limestone by the sediment. So you see 34, 24, 5 and 26%. The idea is to get a composition which is in accordance with the common practice in cement industry. So what did we do? We first start with the characterization of the raw material, so the sediments and the quarried rocks. So we use techniques that you are probably familiar with, like particle size distribution, which has to be below 100 microns in our case, the density, specific surface area measurements, chemical composition through X-ray fluorescence, determination of crystalline phases by XRD, or a specific study of the clay fraction. Then these are homogenized, pelletized in small beds, and heat treated as shown here, so a ramp 600 Celsius per hour, 1450 dwell temperature and 45 minutes. In fact, these conditions are very close to what is done in a cement plant, and air quenching. So after air quenching, we obtain these beads here, which are crushed and give the cement. On this micrograph, we wanted to check if the microstructure after sintering was similar to what is found in Portland cements. And in fact, here we find with ER1 and S1 sediments the phases which are typical of cement, so the calcium silicates, calcium aluminate. Maybe there are some unexpected polymorphs because there are some additives, some minor elements which can change the polymorphs of the calcium aluminate phases. But in any case, what is interesting to look at is for an application in the building sector, is to look at the compressive strength of this material after 2, 7, or 28 days after setting. Okay? So that's a commercial SEM1, what we call SEM1 cement. So it's a cement without any additive. So we reach at about 28 days 65 megapascals. That's the reference clay we've manufactured with our quarry rocks. So we obtain values which are fairly similar to the commercial product. And here are the data we obtain with these free sediments. Obviously, after 2 days of setting, the compressive strength is not as good as it is for the commercial cement because of these minor phases which develop during sintering. However, if we look, if we look in the long term, we obtain characteristics which are quite close to the commercial product. So it means that by substituting 25 or 30% of the raw materials, the usual raw material by sediments, we obtain a cement which has a characteristic which is very close to a commercial product. So what we conclude from these little examples, okay, we obtain the phases which are found in Portland clinker. We have to have a careful pay attention on the raw materials because some minor elements can change the polymorphs. In terms of economical and geographical impact, if the dam location is very close to a cement plant location, there is a potential synergy to exploit these sediments in the industry. Second example we've done also in our lab is to tailor a microstructure for a specific application. In the case here is the acoustical insulation. According to a survey made by Saint-Gobain about 6 years ago for the French market, it was said that 1 person out of 2 is bothered by the outside noise, and 8% out of 10 are bothered by the noise coming from its own housing. So reduction of noise transmission through floor, ceiling assemblies, or through adjacent joining walls between neighboring units or through the windows is a major request in new construction or rehabilitation of dwellings. So gypsum board are already used in a multi-layer alone or a multi-layer configuration. I guess here all these, the panels are in gypsum. But they're also used increasingly as facing materials or interior walls. because, first of all, of their acoustic properties. Second characteristic is their good fire endurance. In terms of regulation, it's quite important. And also for their thermal insulation characteristics. But what is less well known, what was less well known, is what was the relation between the gypsum microstructure and the acoustical insulation. So what was our contribution in this work is we showed that by tailoring the microstructure, we managed to manufacture gypsum boards with remarkable acoustical insulation. Just to give you two parameters which are important in acoustical insulation. The first one is what we call the sound transmission loss. Basically, when there is a noise level L1 in one room, when it goes across a partition wall, then it drops down to L2, and obviously what is required is to have R as high as possible so that a person living in this room hear little. Second important parameter is what we call the critical frequency. So on this graph, you have the transmission loss as a function of frequency, so it increases with the frequency. But there is a specific frequency which is quite detrimental because there is a sudden drop of the sound transmission loss due to resonance phenomena. And of course, what we are looking for is to have this critical frequency as far as possible from the human sensitive range, which is between 300 and 1500 hertz. So how can we do? If we look at the critical frequency, there are some materials parameters which are here. So the mass per unit area, the bending stiffness, Young's modulus, and the bulk density as Poisson ratio. So the critical frequency is roughly inversely proportional to Young's modulus. Transmission coefficient, we have a relation which is slightly more complicated, but again, we have materials parameter, specific mass per unit surface, and Young's modulus. So what were the possible experimental strategy we explore to modify both R and the critical frequency? The first one was to change the plaster over water ratio, in other words, to dilute more the plaster, meaning that Young's modulus should decrease, the porosity should increase, but the critical frequency should also increase. Second strategy is to make a composite between plaster and cork, so something lighter, less rigid than plaster. Again, Young's modulus increases. Third strategy is to use an additive to modify the crystal growth. And by this, we managed to modify the number of contact points between crystals. So here are the experimental results we obtained. Transmission loss as a function of frequency. So in red here, you have a commercial product. Okay, so the critical frequency is about 3000 hertz. If we add cork, not much change. We even also decrease the critical frequency. If we increase the water over plaster ratio, okay, we shift the critical frequency, but we decrease the mechanical strength. The best result we obtained was with the addition of additive because the flexural strength was maintained, and we managed to shift the critical frequency to about 4500 hertz. How do we explain that? If we look at the microstructure of gypsum without additive, we have needle-like structure. When we have an addition of citric acid in very small quantity, we obtain platelets. And why do we have this morphology? Because we showed that the molecules of the citric acid adsorbed on specific gypsum faces, 1, 2, 0, and minus 1, 2, 1, which have found to be the most reactive faces. And because of this adsorption, it modified the crystal growth, as shown by the Bravais, Friedel, Donnet-Ecker theory. Modifying the crystal growth, there is a modification of the morphology. And therefore, we modified the number of contacts between the gypsum crystals. So we did a small calculation. Try to calculate the number of contacts in this configuration where we have needles and when we have parallelepipeds. Obviously, the number of contacts per unit length for gypsum with the additive is about 6 times lower than in the case of gypsum without any additive. So, because of that, we decrease Young's modulus, but we increase the critical frequency. Last example is the use of eco-friendly additive for ceramic processing. And I give you the example of the tape casting of alumina. So what is tape casting? Basically, we mix a ceramic powder with additives. So we have a binder, plasticizer, dispersant to obtain a ceramic suspension, which is cast onto a substrate. And after a good drying, the ceramic tape should be very supple, but without any cracks, without any defaults. Then removal, debinding of the additive and sintering, we obtain a ceramic which can be used for applications such as microelectronics or membranes for gas separation. But because at the present time these additives they come from the petrochemical industry, they can present risk for the operator health, especially if they are manipulated in large quantities, can have a potential impact on the environment and may be shortly forbidden by the REACH regulation. We have been looking at alternatives to replace these additives by molecules which respect the green chemistry principle. So I will show you what we've done with the dispersant and the binder. Let's start with the dispersant. So the way to check if a dispersant is efficient or not is to measure what we call the zeta potential, which is the surface charge of the particle, as a function of the pH. So in that case, it's an alumina powder. So alumina powder alone in water, pH is 9, but because there is no surface charge, there is a sedimentation. So it's not very good to prepare a good suspension. The dispersant which is commonly used at the present time is polymetacrylate, ammonium polymetacrylate called d'Arvan, which gives here at pH 9 a good zeta potential, minus 45, so very good dispersion. So what we've done is simply replace this d'Arvan by lineosulfonate dispersant, which is in fact extracted from the maritime pine of land, which is very close to here, which has, here you have the chemical formula with some ammonium ions. And again, what is interesting is that we managed to obtain a zeta potential, which is close to minus 40, so very good for obtaining a good dispersion of the alumina. Another parameter which we measure when we want to check that an additive is efficient as a dispersion is to measure the viscosity as a function of the amount of dispersion. And for tape casting, what we want is to have the viscosity as low as possible. Again, if we put 1%, which is a minute quantity of this additive in the suspension, we obtain a viscosity which is very similar to what we obtain with the d'Arvan. So ammonium lineosulfonate, for us, it's a good dispersant for aluminum. Second additive is the binder. So we used citrus peel binder, okay? And how do we measure that a binder is adsorbed or not on a ceramic powder? We measured the thickness of the adsorbed layer by microbalance. And we have seen that the thickness of the adsorbed pectin layer is about 230 angstroms, so 23 nanometers. So it means we have a nice shell of binder around the alumina powder. Therefore, we have a very good distribution of the particle in the medium. So Now we found a good binder, a good dispersion. We are going to prepare a suspension. First of all, we start with the pectin. So pectin, you obtain a gel, okay? And we've tried 3 different protocols to check whether there was an incidence of the order of introduction of the additive on the rheology. So we started with alumina powder, and the dispersion added in one go in the pectin gel. Second protocol was to add alumina alone in the gel, and the third protocol was to first mix the alumina with the dispersant and then to add it in the pectin gel. So first protocol, again, alumina plus sulfonate added in the pectin gel. What we obtain is a good zeta potential, -50, a small conductivity due to ammonium ion, and a shear stress, which is quite adapted to the tape casting process. For interpreting this data, we think that there is a competition between the adsorption of the dispersion here in red and the pectin, the binder, okay, as shown here. So we have a shell around this alumina particle, but not too much interaction between the polymeric molecule. Second protocol, without any dispersion, only the pectin. Shear stress, okay, but potential is not good at all, so we have sedimentation of the suspension. So it shows that we need to put the dispersion in the solution to obtain a good rheology. Last protocol, so we mix the alumina with the dispersion first, so there is adsorption of the first shell of adsorption of the dispersion around the particle, and then we add the pectin. So the pectin is attaching to the dispersion. It means you have a huge shell of organic molecules around the alumina powder, and the result is a very thick suspension, okay, despite the fact that the potential is good, but very thick suspension which cannot be tape cast. So the best protocol was the first one, and obviously that's a typical shear stress as a function of shear rate curve here, okay, so we have a shear thinning behavior and a viscosity which drops down to value which are quite compatible to obtain a ceramic tape. And after sintering at 1600, we have a density around 93%. As you can imagine, for this specific application, we try to have a density as high as possible. So through this example, it was possible to obtain dense ceramic tapes with a water-based tape cutting process by using eco-friendly additives. Ammonium sulfonate is a good alternative to traditional dispersion, and of course the order of introduction plays a strong role on the final characteristic of the alumina slurries. Conclusion. So through this example, I couldn't give you all the example of all the ceramics, but just a little focus on the environmental aspect. In ceramics, of course, at the minute there is a current trend towards the valorization of waste, okay? The use of bioadditive, also to use processes which leads to product with appropriate physical properties. But if we look for the industrial application of all this research, there is a need for a sound life cycle analysis. In other words, to say where to put the effort. Do we have to put the effort on the recycling, on the process itself? That's still an open question, and it depends on the ceramic sector. And also, all these are very good, but we need to have a very sound balance between the environmental benefits we can have and the economic and social consequences. Last slide to say, you're going to tell me what is the link between the ancient and the current ceramics. Well, I would say that in fact the processes which are used in technical ceramic, they started with the use of processes which are applied to clay minerals. So there is some continuity between the ancient processes and the current processes. Obviously now we have other processes, but Again, it's a paste, a rheology, and it's mixing, additive, and so on. What we have in common is we use the same, I guess, the same tools for looking at the physics and the chemistry of these materials. And I think that there's a concern, this is a concern at least for the cement industry, but I guess it's probably a wider concern, because there is a lot of data, published data, because there are many technical books and so on. So we need to have a good data management or curation of the data. What do I mean by that? Is that there are many data which are available. Again, I'm talking about the cement or the concrete field. You have numerical data, categorical data depending on the application, Boolean data, meaning that these data are true or false, structured data. But, and this data must come associated with information. In other words, is to say where, when were they generated, 10 years, 20, 50 years ago? What was the source of the data? Was it a lab? Was it an industry or technical center? What were the kinds of tests, protocol to generate the data? Okay, so I guess these are probably also questions you have in your field. So a sort of cleaning or data curation must include a sort of, I would say, computing approach or a big data approach to search and retrieve the data. And also, since we have also many images, graphics, and so on, so these need to be entered into a registry system to retrieve them when they are needed, and also the interface with current scientific work. Okay, so thank you very much for your attention. I would like to thank all my colleagues who participated one way or another to the work I've been showing, and I'm very happy to answer questions if I can.